Hi everyone, this is Mrs. Snowbeck. Today we are going to do Unit 9, Lesson 2, Lateral Area and Surface Area of Prisms and Cylinders. All of the shapes that you see here are prisms. Let's jot down the definition. A prism is a solid with two parallel and congruent bases. Notice I use the symbols just to make it quicker to write. Connected by parallelogram faces. So a prism is a solid. It has two bases, and the bases are going to be parallel and congruent. And then they're connected by parallelograms. So in this first prism that you see, the triangles are the bases. So the bases are parallel to each other and congruent to each other. In the pentagonal prism, same thing. The pentagons are the bases. The hexagonal prism, the hexagons are the bases. For rectangular prisms and cubes, it's a little tricky because there could be several different sides that could be considered the bases. So for our class purposes, just so that we all do it the same, when you have a rectangular prism, you're going to just use the top and bottom as your bases. So we're going to start out by drawing some of these three-dimensional objects. We're going to first draw the triangular prism, and there's several ways you can draw this. One way is you could make a triangle, drop down two parallel and congruent segments, connect the bottoms, and then what you're going to do is you're going to dot the bottom triangle. You want to try to make that triangle the same size as the top one. And then you're going to dot up to the top. Those dotted lines are called hidden lines, and they are lines that you would actually not see because they would be in the back of the object. Now, this one is just fine. Some people also draw their triangular prism like this. Either way is fine. Next, we're going to draw a rectangular prism. So the way that I do this is I start by drawing a rectangle. Then I'm going to draw in 4 segments that are kind of angling out, and they have to be parallel and they have to be congruent, but the 4th one is going to be dotted because that one's hidden. So all 4 of these should be parallel to each other. All 4 of these should be the same length, but the 4th one is dotted. Now I connect the tops. I connect the side. And then I dot over to the right and I dot up to the top. And that is pretty close. I could neaten it up a little bit, but good enough. Let's do the cube. Start the same way. Make a square this time. Angle off 4 segments that are parallel and congruent to each other, but the 4th one has to be dotted. Connect the tops, connect the sides, and then dot to the right and dot up. Let's do a pentagonal prism. So this time you want to try to draw a pentagon. I try to draw a regular pentagon where they're all equal sides. You don't have to. Then I drop down 4 segments. So I drop down 1, 2, 3, 4. Notice how they are parallel to each other. And they should also be congruent to each other. The 2 that start down lower have to go lower. Then you connect the bottoms. And then what I do is I finish off the pentagon with dotted lines, the bottom pentagon, and then I connect up to the top with a dotted line. And there's our pentagonal prism. And then next, let's do the hexagonal prism. So start by drawing a hexagon. Again, I draw the best I can to get a regular hexagon. Drop down 4 segments. The 2 that start lower have to go lower. Connect the bottoms. And now we just need to get the hidden line. So we can see 3 of the 6 sides on that bottom hexagon. So we have to draw in 1, 2, 3 more. Connect up to the top, and I try to offset it a little bit so that we can see them so that they're not completely behind the front ones. And there we have it. Let's talk about some of the parts of a prism. So the bases, we already talked about these. There's going to be two bases, and the two bases have to be two parallel and congruent sides of the prism. Then let's talk about lateral faces. So the lateral faces are like the sides. So these are just going to be the sides of the prism, and they're not bases. They're the sides that aren't the bases. Next we have lateral edge. And the lateral edge is where two lateral faces meet. Okay, so let's look at our shapes here. You can see we have two prisms. One is right and one is oblique. So the right prism is standing upright. The oblique prism is leaning over, like the Leaning Tower of Pisa. It's not directly at a right angle to the ground. So the bases, an example of a base would be like that top face up there. A lateral face would be one of the sides, and a lateral edge would be, let me outline it like this right here. So a lateral edge would be that edge right along the edge there. Now a base edge is going to be where a lateral face meets a base. So let's write that, where a lateral face meets a base is going to be a base edge. On this picture, an example of a base edge is right down here. This would be a base edge. Altitude is the height. Now, the way that you define the height, sometimes your prism is oblique and it's tipping over. So the way that you should define your height is the distance between the bases. The distance between the bases. So sometimes it's, the same as your lateral face, but sometimes your height might be outside of your object. It has to be perpendicular to the base. And then a cross section is like a slice of the object or a slice of the prism. I'll just write that, a slice of the prism. Like I think about if I have a block of cheese and I cut it down the middle and I open up that block of cheese to see where I cut. Whatever shape that cut is, that is the cross section or a slice of the block of cheese. Oh wait, did I mention the Leaning Tower of Pisa? Yeah, there I am holding it up, by the way. Literally. Oh no, Mr. Helmstetter, don't tip over the Leaning Tower of Pisa onto me and Miss Laube and Miss Meyer. Ah! No worries. I'll save the day. I know what you're thinking. A little cheesy. You're right. Okay, let's next talk about what is a lateral area. Well, you know how the lateral faces are the sides of the prism? The lateral area is the sum of all those sides. So it's the sum of the areas of the lateral faces. In other words, find the areas of all the sides that aren't the bases and add them up. There is a formula. The formula goes like this. Lateral area equals PH. And I purposely used a lowercase p and a capital H, so please do that. P stands for perimeter of the base. H stands for height of the prism, or height of the object. So imagine if you found the net of this triangular pyramid. If you unfolded it and laid it out flat, it would look like this. The sides are basically rectangles, right? Those sides are rectangles. And so if we found each of those rectangles and added them together, we would get the lateral area. Or we could just make one big rectangle and take the distance down here times the distance right here, like base times height. Well, the base is going to be the same as the perimeter around the base of your object. And so find the perimeter around the bottom, multiply by the height. Okay, so let's talk about what type of prism is this? Well, we have to have a 3-word answer. First, we're going to decide, is it right or oblique? I think because of this little 90-degree mark, it is going to be a right prism. The base is triangular, so this is going to be a right triangular prism. I want you to notice that the triangle is not on the bottom, but I know it's a triangular prism because the two sides that are parallel and congruent are the triangles. That's how I determine my bases, and I name the prism by the bases. So this is a triangular prism, a right triangular prism. How many vertices does it have? Well, vertices are like corners, and so I'm going to just show you. Here's 1, 2, 3, 4, 5, 6. So it has 6 vertices. How many total faces does it have? Well, faces, if it says total faces, that means all the faces, including the bases. So it's got 3 rectangles around the sides, and it has 2 triangles at the bases. So altogether there are 5 faces, but 3 of them are lateral faces. 3 of them are like sides. How many edges does it have? All right, let me show you what I mean by edges. Edges include base edges and lateral edges since it doesn't specify. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 total edges. Part F, what is the shape of a cross section parallel to the bases? Okay, this means I'm going to slice it, and I'm going to slice it parallel to the bases. So imagine I slice it, and it's parallel to the bases. What shape would that slice be? It would be a triangle. And then last but not least, find the lateral area of the prism. Lateral area is perimeter of the base times the height of the object. Okay, so when you look at this shape, just got to erase some marks there. We need to find the perimeter of the base. Remember, the base is the triangle, the pink triangle. So we have to find this third side in order to get the perimeter around it. I know I'm going to add up the 6, the 5, but then I need this side as well. So to get that side, I'm going to have to do 5 squared plus 6 squared equals x squared. I'm going to have to do a little Pythagorean theorem. So 25 plus 36, that adds up to 61. Take the square root of 61, and you get approximately 7.8. So what we just learned is this distance is 7.8, and now I can get the perimeter. I would take the 7.8 plus the 6 plus the 5. A lot of people make the mistake of thinking the bottom is the base, like the 7 by 6 rectangle. But no, remember your base has to be the two sides that are parallel and congruent. So in this case, the 2 triangles are the only 2 parallel sides. If you add up all of those things, 18.8 is your perimeter. Next, what is the height of this object? Well, this prism is laying on its side, so the height is actually the 7. The 7 is the distance between the 2 bases. So the height is 7 centimeters. So now we can find lateral area. Lateral area is pH, so it's 18.8 times 7. 131.7 centimeters squared. Will you please pause the video and try number 2? When you're done, unpause the video to see if you got it right. So part A, this is a right hexagonal prism. It has 12 vertices. Remember, the vertices are like the corners, so there's 6 on this end and 6 on the other end. How many total faces? Well, there's 6 sides plus 2 bases, so that means 8 total faces. But 6 of them are lateral faces. Remember, the lateral faces are like the sides, like this rectangle right here is a lateral face. There'd be 6 of those. How many edges? Well, there's 18. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, what shape is the cross section that's perpendicular to the base? So this is a little different. This time we're trying to cut this perpendicular to the base. So not parallel to the base. So you have to kind of imagine, what would that look like if I sliced it? Well, there's a lot of ways that you could slice this, but I guess one way would be like that. Imagine you slice it through the top. And so what section do you get? You do get a rectangle. The bases are the hexagons. So slice through those and you would get a rectangle. Now, lateral area is perimeter of the base times the height of the object. Perimeter of the base, each of those sides is 5. I guess it is a regular hexagon. It doesn't really say that. So we would do 5 times 6. So the perimeter around this base is 5, 5, 5, 5, 5, 5. 6 of them, so that's 30. The height of this object is the 12. 12 is the distance between the two bases. This is laying on its side, so its height is going sideways. So lateral area is going to be 30 times 12. 30 times 12 is 360 centimeters squared. That's the total lateral area, the area around the sides of the object. Now let's talk about surface area of a prism and how that's different from lateral area of a prism. Lateral area is only the area on the sides of the object. Surface area, you have to add the two bases. It's any surface you can touch on the outside of the prism. So surface area, the formula goes perimeter of the base times the height of the object, just like lateral area, but then add 2 base areas. And again, I'm using a capital B on purpose. P stands for perimeter of base. Capital H stands for height of the prism, or height of the object. And capital B stands for area of the base. So you have to actually find those 2 areas and add them on. Let's do this. Number 3, find the surface area of the rectangular prism. Notice the base is a rectangle. For rectangular prisms, for our class purposes, the bases will be the top and bottom, because technically other sides could be the bases, but we're going to use top and bottom. Formula for surface area of a prism is PH plus 2B. Let's go letter by letter. So P stands for perimeter of the base. The base is 9 by 4 by 9 by 4. So add those up. 9 plus 4 plus 9 plus 4 is 26. So the distance around this base is the perimeter, which is 26. H, height of the object. The distance between the two bases. So it's 6. 2 is going to stay 2. So now we have capital B. Capital B stands for area of the base. The base is a rectangle. It's 9 by 4. To find the area of a rectangle, you do its base times height. And now is when I use little b and little h. Because to find the area of the base, I have to take its base times its height, which is going to be 9 times 4, which is 36. Cool, we have all of our things. Plug them into your formula. P is 26 times H, which is 6, plus 2 times capital B, which is 36. Simplify that all up, and you should get 228 feet squared. Go ahead and practice typing that in and see if you actually do get 228. Number 4, find the surface area of the triangular prism. Notice they're giving you a clue here. The base is not the bottom. The bases are the two sides that are parallel and congruent to each other. This triangle and this triangle are the bases. So you have to be careful. Those triangular ones really mess people up sometimes. All right, formula. We have surface area, we have prism. So surface area for a prism is PH plus 2B. Let's go through the letters, starting with P. We need the perimeter of the base. The base is not 12 by 8. The base is this triangle. We have to find the third side before we can do the perimeter. So 12 squared plus 12 squared equals x squared. Do a little Pythagorean theorem. You get 144 plus 144 equals x squared. That is 288 equals x squared. And when you take the square root of 288, it's 16.97. So let's see here. I'm going to erase my x. And this is going to be 16.97. Almost 17. Can we now find the perimeter around that triangle, which is the base? Yes, 12 plus 12 plus 16.97. Add those up. You get 40.97. Height. Okay, look at your object for a minute. Try to figure out what's the height. The height is not 12 if you're thinking 12. No. The height is the distance between the bases. This thing is laying on its side. The height is actually the 8, the distance between the triangles. Next, we're going to 2 stays 2, so next we're going to do the B. B is area of the base. The base is a triangle. How do you find the area of a triangle? Base times height divide by 2. This is when we use the little b, the little h. So look at only your triangle. What two sides would be considered the base and the height of the triangle? Well, they have to be perpendicular, so they're going to be the 12 and the 12. So 12 times 12 divided by 2 should give you the base area. That is 72. Sweet, we have all of our numbers. Let's plug them in. So surface area is P, which is 40.97, times H, which is 8, plus 2, 72. Go ahead and practice typing that into your calculator. And you should get approximately 471.76. And think about labeling. It's a surface area. Any kind of area is going to have square units. It's all the area you can touch on the outside of this shape. Awesome. Will you guys try number 5? Pause the video. Try to find the surface area of this rectangular prism. When you're done, unpause the video. So here's my work. Go ahead if you need to pause here so you can check your numbers. You should have gotten 360 centimeters squared for your final answer. That wraps it up. Will you guys please try Unit 9, Practice 2? If you need help, let me know. Have a great day.